welcome everybody to our presentation today on the best practices for electrical safety during maintenance activities. And my name is Justin Gall, and I'm going to start this out with a little scenario just to kind of paint the picture of where we're going to go with our conversation today. And that is, imagine this. A few years ago, an experienced electrician walked into a manufacturing plant for what should have been a routine maintenance call. The job was planned, labeled, and locked out, just like it always was. But one assumption that a downstream panel was de-energized nearly cost him his life. So what saved him? A last-minute pre-job briefing where someone asked, did we verify the last connection point? And that one question sparked a check and revealed a serious hazard that no one had seen. That story isn't rare. It's happening in facilities, data centers, and job sites every day. And electrical safety isn't just about PPE or paperwork. It's about the conversations we have and the culture we build and the decisions that we make when no one is looking. So today we're digging into what really makes electrical safety work from a shock and arc flash mitigation perspective, as well as managing safety programs and cutting through common misconceptions. Whether you're leading teams, engineering safety plans, or protecting uptime in a data center, this conversation is for you. I'm Justin Gall with CBS ArcSafe, and I'm your moderator today. And joining me, we have two seasoned experts from the field, each with years of real world experience helping teams safely navigate high-risk electrical environments. So let's start with some quick introductions of our panelists. Mose, introduce yourself, sir.
Sure. Mose Ramey, CBS Field Services. I've been working in the electrical maintenance and testing industry since 1997. I'll let y'all do the math on that. And certainly have had a lot of experiences coming into the industry without much experience. And once again, some challenges and industry events that have occurred over my career, and I'm happy to share with people and raise their awareness.
Great. And Dave?
I'm Dave Krieger. I'm with Premier Power Maintenance. Let me see, I've been in the electrical business a little bit longer than Mose. I started back in the mid-90s, 1994. Originally part of the Army Prime Power program, where they teach you everything you need to do and don't give you anything to do it with. I will admit, I was a guy that used to play with knobs and would open doors without understanding consequences of doing that. And through a few of challenging events in my own career, I came to respect electrical safety in the workplace, and have since then very much embraced electrical safety, not only for my own safety, but those that work around me and those that are in my organizations that I help oversee.
I want you to hold that thought there, Dave, because I'm going to ask you another question that's even more personal in nature. But first, I don't think I heard where are you coming to us from, Dave? Are you in Indianapolis?
Indianapolis. Mm-hmm. Indianapolis, okay. Eastern time zone. Yep.
Good deal. And Mose is in Nashville, right?
That is correct. Nashville, Tennessee.
So my first question, kind of getting this conversational style discussion going for us, is think about your personal why when it comes to electrical safety. You know, for me, I look back and my dad was an electrician in the 70s, 80s, and 90s at a DuPont plant in Delaware. And it wasn't until I got in the industry that I actually understood, I guess, the risks that were taken and the hazards that he dealt with on a daily basis, and never truly appreciated it until I, got much older and involved in the industry. So for me, it comes back to family and wanting to see everybody get home safely, just like it was for me as a kid when I didn't know that. But how about you guys? Mose, how about yourself?
Yeah, my personal why definitely comes from a desire to begin to educate the stream of new individuals coming into the industry, and the focus that the industry has taken about making sure that people are qualified workers, and really that boils down to their awareness. And the more we can raise awareness, the better they're going to be able to operate in any environment. And I wish I could find this, attributed this quote to, is that once an accident begins, the ultimate outcome is largely a matter of luck. So if we can avoid events, and if we do have an event, if we can put things in place that make us more lucky, then we're going to have a safer work culture. And then that's really what drives me to get up every morning and educate folks.
Nice. Thank you, most. Dave, how about you, sir? That personal
My
why.
my personal why goes back to when I first left the military and started with a testing organization. I did something that I have never done again. It left some scars. And then I realized the first safety training class that I went to, it was a 2-day training class, and the instructor just kind of read from OSHA regulations and read from some other standards at the time that weren't standards. And then I realized at the end of the 2 days, I really didn't understand anything that I just talked about or that the instructor had just talked about. So I had made a promise to myself that if I ever had a chance to teach electrical safety, I would try to put the why into the learning. So that people understand why they're doing what they're doing, not just, because the regulation says I'm trying to do this. So early in my career, I did a lot of electrical safety training, and I found that I really had a good feeling about what I was doing to help others understand why we're doing what we're doing and why we're following the rules that we are in our industry today.
Great. So I think looking at, where the job starts for you all are, experts out in the field, doing field service work and maintenance. So you think about the beginning of the job of the workday, what elements make for an effective pre-job safety briefing before performing maintenance? And I guess a follow on to that also would be who has or shares in that responsibility for conducting those?
Go ahead, Dave. I can see you're ready to start.
Okay. Well, obviously, maintenance is something that's dear to my heart. It's one of our core businesses here at Premier Power, thus the name Premier Power Maintenance. So the responsibility for a safe work procedure, a safe work process, especially on large outages, is everyone's responsibility, including our customers. The customers share in responsibility of communicating to us, the contractors on the job, whatever hazards may be unique to their environment, or even such things as arc flash labeling and such that we've all come to expect to be on the equipment, and that is the customer's responsibility to provide that information to us. So unlike acceptance testing, more than likely, the equipment's just been taken out of service to perform maintenance on it, because very little is done while it's energized. And that in itself could possibly leave some hazards. And it's also, because you have such a short duration of time, you have to be very specific in your job assignments and your expectations of the team, because it's usually, hey, we're shutting the power down at 6 and it's got to be back on by noon, things like that. So it becomes a very critical event to ensure that everybody understands their part of the process, their part of working safely on the job. Our stop work program. If you see something, you got to say something. So that communication process is extremely important, and maybe more so in maintenance than acceptance testing, where generally the equipment's not energized.
Yeah, absolutely. And as Dave mentioned, it is a shared responsibility by all. And it's interesting too, and we can go back and forth on this a little bit, that oftentimes it's not best to say have the most experienced person do the JHA or the pre-job safety brief, but it's better to get kind of a middle guy, new guy, and start helping them learn, because they're also going to look and possibly see things that maybe I would just know is going to be a hazard. And that's where we can get into, sometimes we hear a lot about people just checking the box, right?
Yeah.
A lot of our forms are checklists, and checklists make us safe. That's why airplanes don't crash, right? Because pilots use checklists. And but if you just do it to check the box, then you're really not accomplishing the spirit of why we stop and we do a pre-job safety brief. So instead of just checking the ladder or checking the box for ladder safety or checking the box for lockout tagout, really spend some time and go through why that's on the checklist. If you're using a ladder, there's a reason it's on the checklist. If there is a lockout that needs to be put into place, those things need to be noted and discussed and why they're important. Particularly, like I say, when it comes to the electrical hazard. But I always like to remind people too that there's a lot of hazards on jobs, particularly maintenance jobs, that aren't electrically related. So once again, we can't ignore that there are more hazards out there than just the electrical hazards, which obviously is the primary focus of what we're talking about today.
Yeah, no, thanks, Mose and Dave.
But can I add one more thing to that? And Mose alluded to that. Lockout, tagout, that isolation process is so much more important in a maintenance activity than, say, an acceptance testing activity. And very often we have to rely on the customer to understand their own system, because we travel from job site to job site to job site, so we don't always have critical memory about unique things about lockout tagout at a certain facility. So we do have to work very much close hand in hand with the customer to understand where our isolation points are, where our lockout tagout is. And I would encourage anybody to witness that themselves. We've had cases where the customer said, yeah, we're all locked out down to here. And then we do a walk of the lockouts and we find out it's not exactly the way the customer portrayed it. So obviously in a maintenance situation, that's much more important to understand where lockout tagout is and make sure that you've got things verified as dead. And if it's medium voltage, of course, grounded before you start your work.
Yeah, and it's super critical in that role, and it's obviously part of the new standard. NFPA 70B being a new standard, is that they got to have a good single line drawing too, right? We depend on the customer to have that single line drawing to help us walk through those lockouts. So it is definitely that shared responsibility with the customer to make sure they've got accurate documentation.
Yeah, is that something that you would investigate with a customer before starting a job, whether they have that in place or not? Because I'm sure there's, depending on the customer site or the end user location, that there's often got to be times where that's really not communicated well.
Dave?
Yeah, so that in itself is a double-edged sword. And I'll tell a quick story here. There was a facility that we used to do the maintenance at every other year. And it seemed like the same team, the same job lead, year after year, did this outage. It was a nighttime outage at a banking facility. And in one year we got in and we had everybody staged. We had people on multiple floors to do the maintenance on transformers and such. And everybody was ready to go. People in front of the switchgear ready to go. Midnight, the lights go out like they had every year in the past. And this particular time, midnight, the lights went out, and 5 seconds later, the lights came back on. And it was because the customer had installed a backup generation, and our job lead, who had led this project multiple times, never asked if there was anything that changed on the customer's facility. And in fact, it had. And that could have been catastrophic. We had 35 people on that job that could have been in gear had they waited, more than 5 seconds before that generator kicked in. So having a one-line diagram is absolutely essential, but it has to be up to date and reviewed each time to see if there's been changes. And of course, whenever we're working with a new customer where we haven't worked before, that's absolutely a must to get a look at that one-line diagram before we start planning the maintenance with the customer.
Yeah, great.
Yeah, but not without its challenges, right? Because with any project, teams are going from site to site, and and once again, it can be while it's ideally part of the job planning, you have the one line when you're typically putting a proposal together, but then the team taking the time to actually go through it, and I think I would like to stress that sometimes I don't want to say we're rushing, but we are going from job to job in the field. People that are on this call 44 be out there. A lot of you probably understand, like, you don't have a whole day to get ready for the lockout tag on the job you're going to do tomorrow. But if you spent just 10 minutes going over the drawings, talking with the customer, making sure that that the plans are in place, that those 10 minutes will be they're infinitely more than doing nothing ahead of time. So once again, take advantage of those small opportunities.
What you're talking about a lot I'm hearing is around communication. And that was leading into one of my next questions was so much of electrical safety actually revolves around effective communication. And I also heard something earlier mentioned about pairing some younger techs with more experienced people. How do you recommend tailoring safety communications during maintenance? And it sounds like it starts right there at the very beginning with the customer themselves.
Most?
Yeah, I think when it comes to safety communication, it really, you know what, it's really kind of, I think, following some of those safety obligations that we should all operate under. If you've never heard that before for our viewers and our listeners, there's three safety obligations: the obligation to work safe, the obligation to stop the unsafe act of others, and the obligation that if you're asked to stop, that you listen, right? Because everybody sees something a little bit different, and if you're afraid to speak up, then you might have to bear the consequences of knowing you could have prevented an accident. There are a lot of people that have stood by and watched somebody do something they felt was unsafe. It may not have been, but their observation was it was unsafe, and they were afraid to say something. They felt like maybe they didn't have the authority, they didn't have the responsibility to stop. And really, if somebody ever asks you to stop, you just got to have a little bit of grace and a little bit of be humble and hear the person out. And I think that those types of communications and having a little bit of bravery, if that's what it takes to say time out or bring something up to somebody's attention, is well spent.
Yeah, so kind of changing gears a little bit, since we're talking about maintenance, obviously we're kind of alluding to the idea of equipment condition and the frequency of maintenance. How's that tie in with safety? And this might be where we look at NFPA 70B, but what guidance is out there about the frequency of maintenance types? For example, and I'll just say I was recently at a customer site where we saw switch spare circuit breakers sitting on the floor. One was covered with a plastic bag and it said last tested in 2020. And the guys there were relatively new to the facility and were not there when that testing took place for those spare breakers. And to me, that sounds like it creates kind of a challenge if I were in their shoes about, can I trust this is ready to roll? And if it's, if that was 2020, we're at the 5-year mark for it. So I'd say it's time again anyway. But what about the guidance out there around the equipment condition and the frequency of maintenance?
I think there's a direct impact on the equipment maintenance and safety in the workplace. We've been asking our technicians, electricians, to really get their arms around Chapter 1 of 70E to understand, how to protect themselves there. But and it's been effective. If you look at statistics over the years, you'll see it's been a pretty good decline in electrical accidents. And then we hit a plateau in about 2019. And we still continue to have about the same number of accidents, but it seemed more and more were because of faulty operation of equipment or equipment that wasn't maintained properly, didn't do what it was supposed to do, or didn't do what it was supposed to do in a fast enough time. So there was a real focus then on maintenance. Now it's been in Chapter 2 of 70E, 3 iterations now, but when 70B came out, and became a standard. Now this puts us, levels up the whole playing field about maintenance, and there is a lot of direction, both in 70B and of course in the NETA MTS about frequency of maintenance. And something that hasn't been tested in 5 years has to go in a 1 year every year until your maintenance and testing can prove that device is not degraded one bit. Then you can move it to a 3-year. But then you test it again after 3 years, and if it still hasn't degraded, still performs excellent, then according to 70B, you can move it to a 5-year rotation. And there's some other variances in there, criticality of the circuit, environment, and things like that, just like the MTS had. But it's so important from the electrical safety perspective that they've dedicated 6 pages in NFPA 70E just for what we think are the most important maintenance activities you need to do in your facility. And the one right after training your staff what the maintenance requirements are is a one-line diagram. And then two paragraphs after one-line diagram is the performance testing and documentation of your circuit protection, because that's your first line of defense in minimizing your exposure during an arc flash event. So those things are extremely important. And one of my pet peeves, which was included in almost every piece of equipment that's in 70B, as far as what you should be doing for maintenance, they've included now grounding, because grounding is my pet peeve. We all want to work on brown, orange, and yellow, or black, red, and blue. No one ever wants to mess around with green, but that's probably the most important wiring system you have in a facility.
Right. Well, we're going to touch on that again in a minute. You know, I'm thinking about that NFPA 70B. How aware do you feel like the industry is with regard to the changes and what has become a shall with NFPA 70B on the customer or end user level?
Yeah, speaking, this is a bit anecdotally, I would say that the industry is actually coming up to speed maybe more quickly than they did with 70E back in 2000, when a lot of people started hearing about NFPA 70E, because we're getting a lot of calls from facilities of all sizes, really, that are more focused and more intentional about being safe, right? They want to meet the what is now a standard of NFPA 70B. And so a lot of facilities that had just kind of historically just said, we're too small, we don't have big enough equipment, whatever they would say, all the excuses, whether it's a company or a corporation-wide thing or just an individual plant, culture changing. I've seen a lot of folks that are curious about 70B and curious about how, like Dave mentioned, things as simple as making sure that your protective devices, your circuit breaker trip units, your protective relays, that those devices are working. Because once again, if they are not working and you've had the culture where you've got an arc flash study, the arc flash study really is invalid at that point if you haven't had consistent, proper, documented maintenance that validates that the protective devices are working. So I definitely have seen a good trend toward that. Dave, what have you guys seen?
Yeah, I see a little bit of a mix. We've had customers that said, yeah, NFPA, it's a standard now, but my jurisdiction having authority, which is the enforcement authority for any of the NFPA products, hasn't adopted that code yet. Hasn't adopted the 2023 code yet. And my response to that is maintenance of the equipment, whether it's code driven or not, is a good principle, and eventually it is going to catch up. So instead of getting caught with your pants down after an accident, be proactive about maintenance on your equipment. Someone pointed out to me that a willful violation from OSHA starts around $500,000. That buys a lot of maintenance.
It also keeps people out of jail.
Well, yes. So, whether your local jurisdiction's adopted it or not, or is actively enforcing it or not, it's a safety requirement. And there is no grandfathering of safety. If there's a better, safer way to do it, and we all understand what that better, safer way is, you can't put your head in the sand and say that doesn't exist. So after conversations like that with a lot of our customers, they come to realize that this is an eventual issue they're going to have to address, and let's do it proactively now instead of retroactively when an event happens.
Yeah. And once again, different equipment needs different maintenance periodicities, right? We've got modern circuit breakers that maybe don't, we can go 3 to 5 years, as David was, demonstrating. But then there's a lot of equipment out there, and I'll reference two pieces that a lot of people on the call might know: the WLI style high voltage switches, medium voltage switches, and the low voltage Pringle switch or a bolted pressure switch. Those devices need annual maintenance, full stop.
Good point, Mose. Talking about equipment condition, I went through one of your previous presentations and pulled out some photos that I'd like to share with our audience and kind of get you to tell a little bit of background on them. So the first one I've just pulled up here on the screen. What's going on here? What's the
Well,
details on this one?
Well, no good story starts off with I was eating a salad, right? Um, so no, this is a great example, and I do like to tell people this picture and any other picture I ever share with anybody is not AI generated. It is not staged. This is really a condition that we found a plant in, and the 4x4 and the 2x6 or whatever that is that are stuffed up into these circuit breakers are there to force them to stay closed. The customer safety culture aside had a higher importance on reliability, and obviously not much of importance on maintenance to maintain that reliability. So they sacrificed safety 100% for reliability. And so I say it, and it doesn't have to. You don't have to walk into a facility and see 2x4s and 4x4s shoved into breakers to know you got a problem. I mean, just you can walk in and just see good. Do you see good housekeeping, or do you see trash on the floor? Do you see boxes in the equipment room? And so once again, this is just a simple indicator of where the culture of a facility is, and it's always, like I say, you can tell pretty much as soon as you walk into the first equipment room.
That's pretty interesting. So you have culture, and then you have NFPA 70E and NFPA 70B that says this is the standard, but in some places culture still kind of prevails, doesn't it?
I mean, absolutely. I mean, once again, this is just a book. I mean, it's just a book. If people don't value the information, if they don't understand, like I say, like I kicked off, my why is about awareness. The person that shoved that 4x4 up in there probably wasn't fully aware of the tremendous hazard they're creating, not only for people's lives, but the facility could create a fire that could cause the facility to burn to the ground, costing them millions and millions of dollars and possibly injuring dozens of people, right? I think it's just the awareness of why is that wrong.
Yeah.
is a whole in this in a lot of different cultures, not just this particular example. What about you, Dave?
Yeah, I was in a facility the other day, and I should have gotten a picture of the sign, but it was a large fuse disconnect switch, and it said, "Do not open this switch. You will never get it closed again." And and I thought, wow. So I asked the guy that was taking me around the plant. I said, what's that all about? And he goes, "Oh yeah, the electrician that retired 8 years ago wrote that on there before he retired." Is it really? It's been in that condition for 8 years, and that doesn't mean anything to you. That doesn't scare you. It would scare me. If you have equipment that's not going to function correctly, and we're talking about thousands of megawatts of power, sometimes a tremendous amount of power that could be unleashed in a fault, it scares me. But we see all kinds of things like that.
Well, that's a great example of the normalization of deviation, right? Some little thing you just say, it's fine. I'll get to it next week. You just keep normal, and pretty soon you've got a switch that has been known as an issue for 8 years, and nobody's willing to do anything about it because it's just always been that way.
Yeah, and just for anybody that has a question, just to let you know, pop that in the Q&A, and we'll address that in the last few minutes of the presentation. Unless it has to do on topic with what we're talking about, and I find it, I'll make sure we ask it of our panelists here. So, Mose, a couple more photos here, things that you've seen out in the field, maybe things that throw out red flags. I'm not sure what I'm looking at here. What do we got?
Yeah, I'll set the stage here. So a customer called us because there was this red goo leaking out from under their switch gear, and of course, knowing that there's a probable cause, or I'm sorry, what would the phrase be, Dave? Pending signs of a pending failure or something.
Pending failure.
Right? Yeah, is that right? So goo coming out from under the gears, possibly a sign of pending failure. So we had them shut it down and took the cover off, and of course, what we have here is that ring, that kind of reddish gold ring that everybody can see behind the black circuit breaker, is a zero sequence CT that's there for ground fault protection on this circuit. And the red goo that's now in the bottom of the gear is what used to encase or enclose that those turns of wire that create the CT. And this is a very common problem on ITE switchgear. This is obviously it's vintage gear, um, and, and and when we find these, people think they've had some kind of overheating problem. As it turns out, it's just an environmental thing with the resin that they used to cast these 30 years ago, 40 years ago, and they will just melt. They will melt sitting on a shelf in the warehouse. So if you ever see red goo coming out, that's what's going on. But from a safety standpoint, and I'll let Dave speak to this a little bit too, is what we have here is one, we've got metal. Now it is still insulated, but it's laying on the buswork in the back here, so that's a potential failure point, as well as there's no assurity that the ground fault protection system in this gear will work. And once again, this could have been identified with systematic maintenance on an every 2-year, every 3-year rotation and headed this off, because it just doesn't melt it at one time. It's a process. But Dave, what else?
But what sticks out to me on this photo is obviously the lack of insulation around that zero sequence CT. And yes, it is sitting on a bus bar in the back. That's eventually the only thing that's protecting that right now is the a bit of lacquer around the windings of that CT. But if you look at the CT wires, the leads going up to that terminal block, it looks like those wires are melted together. I can't tell from the photo, but that's a common issue. If you open circuit a CT, you're going to cause some real problems here. And that we see this actually more often than you would think. Seeing that red goo at the bottom of a switchgear assembly. So obviously, ground fault protection is very important. We're talking about larger amounts of current, 1,200 amps and up. That's required to have ground fault protection according to the code. So huge issue here, both for personnel safety and for facility safety.
So that's one example. Here's another thing that I think we commonly look for. There's a little corona action there.
Yeah. So this happens once again, kind of like more often than you think, right? We have red jumper cable, 515 kV unshielded jumper cable, and it does not like to be long term in proximity to a grounded plane, or worse yet, in proximity to an alternate, another phase. Now, the potential between this cable and ground might have been, 2,400 volts, but when it's in proximity to its another phase, now we're talking about 4,160. So the stresses are even greater. And once again, this left uncorrected will cause an outage. It'll be an arc flash event. Probably happen at 2:00 in the morning when nobody's around, but it could easily just as easily happen at 2:00 in the afternoon when somebody's in the switchgear room doing their sweeping. So, but this is the kind of thing that is super easy to find when you're doing a routine inspection. And I think I just saw something pop up in the chat about competent person, and Dave might be able to take this into a qualified worker recognizes what's going on here. The new guy just thinks that it's some white dust, wipe it off and don't worry about it and move on, right? Because once again, qualified worker, it takes time to become a qualified worker. You have to see these things in the field or in a presentation like this to begin to recognize them.
Yeah, great point.
Yeah, we've really changed the definition of qualified electrical worker dramatically in the last couple of years. Anybody that's been in the electrical industry or familiar with the electrical industry, over the, just even a short period of time would understand that anything that's got voltage in it is hazardous, and anything that's got current in it can be hazardous. So to say that you understand what the hazards are, yeah, I know there's voltage and current. Okay. But what we're asking our teams to do now is to understand the risk of being tangled up with one of those hazards. And so recognizing, something in this photo, we're talking about a much higher risk of being involved in a flashover event here than if it was well maintained and separated the way it should be. So, we really want our qualified electrical workers to understand the maintenance requirements to maintain a safe distribution system and understand what to look for, especially during those visual mechanical inspections that 70B advocates for practically every piece of equipment.
What do you think about, and this is a question from the field here in our audience, what do you think about condition-based maintenance from a digitized switchgear perspective?
Digitized.
And maybe
Might need some clarification on digitized.
Yeah, Benedicto, if you have more clarification for us, shoot that over to me, and we'll address that toward the end here. Moving on here, Mose, environmental factors. What's happening with this situation?
Yeah, so yeah, this is another great example of environmental factors. So, and this is a great example of the importance of maintenance. Yeah, we do electrical testing. We test insulation resistance and contact resistance and cables and meters but do we check the heaters? This is a WLI style switch that's outdoors, and in the spring and in the fall, when the temperatures swing radically, they can become condensation can occur. And when it does, the condensation gets on the insulator, a little bit of dirt, and you start getting these what look like little cigarette burns at the base of the insulator. Those are little arc flashes. They're little partial discharges that are burning the paint on that particular insulator. And once again, left unchecked, left unmaintenanced, eventually this switch will fail and could possibly expose people to that arc flash energy when it does. So once again, just a great example of and I like to use this one. This is a simple one. This is heaters. Are the heaters working? Dave, what other simple things that people should be thinking of?
Well, the cleanliness and the environment that your switchgear is in, especially if you're in a facility that generates a lot of dust, and some of it can be conductive dust. Simple things like keeping the switchgear clean, keeping the filters clean in the switchgear, or something as simple as keeping the grounds, keeping the weeds cut down in a substation. Those aren't just to make it look pretty. That is to extend the life of the equipment. We often talk about getting maintenance done on some of these pieces of equipment, and we want to go in and rub on some porcelain, and a lot of people think that's a really diminutive project, but it's not. It's extremely important to rub on that porcelain and clean it up, and make sure it has the insulating properties that it needs to have to continue to run safely.
Yeah. If we just hopefully have enough time, this story just came to me. It just came out of nowhere. We talk about cleanliness, and we show you this little example of how even just minor problems in gear can begin to cause problems. We had a customer. It was a foundry, a steel foundry, and this is an example of how resilient electrical equipment can be, even if it doesn't get maintained. The steel dust was so thick, I had to scrape the dust away from the door with my boot so that I could open the door on the switch. Wow. And a lot of our listeners know that there's typically vertical bus and horizontal bus that runs back to cable connections. Mm-hmm. The dust was so deep or so thick, it was pyramided on top of the horizontal bus at the top of the switch, and it was still in service. So I think this equipment's been really well designed. If you let it run like that, eventually it's going to let you down, and it's going to cost you a lot more than just a maintenance outage. So once again, maintain it. It's resilient, but you still need to maintain it every chance you get.
Speaking of outages, let's discuss real quick. This is similar to an experience I recently had, but these are spares sitting on the floor covered with a trash bag. What's the best way to store these spares for that outage coming up, so to make sure they're safe, but also operationally effective?
I would suggest keeping them off the floor, off concrete, because anything that's set on concrete has a tendency to suck moisture out of the concrete into whatever surface is touching there, or it'll accelerate corrosion on the bottom of a steel frame. So get it up off the floor. Cover it with something that's breathable but dust-proof. So if you ever seen those little packages of desiccant that get shipped in all kinds of different products that we buy, that material is breathable. yet it is dust proof and it'll keep dust out of the device. So I don't recommend using black plastic bags. As just the ambient moisture and temperature changes, you'll get condensation inside that bag, and then all your arc chutes, the insulation in your arc chutes, the insulating barriers there will start leaching in that moisture as well. So you'll lose your insulation integrity while it's just sitting on the shelf. Anything to add to that, Mose?
Yeah, I'm going to add that, one of the things I don't like about black trash bag, one, you don't really know what's inside of it. And then two, people see trash bag, they think that's a good place to put their trash, right? So all of a sudden your breaker starts collecting trash and bolts and things could possibly fall into it. So, keeping them in a designated area, once again, cover them so that they stay clean. And, one thing I like to see too, especially when it comes to spares, is like a test report. Included with the breaker. So you actually have the documented evidence the last time it was tested. Obviously, it should have a tested by sticker on there if a company's following standard, testing protocols. But, once again, if it's going to be a legitimately, I got to put it in service spare, you really got to make sure that you're taking great care of it so that you can grab it off the shelf, do at a minimum an insulation resistance test before you put it into service. Just to make sure that something hasn't fallen inside there, or once again, mice and rats can do some crazy stuff, and you'll never know they're in there until it's too late.
Good details. Moving on here, let's think about some common misconceptions. We mentioned we were going to talk about misconceptions in electrical safety, and one that comes to mind for me is if it's low voltage, then it's low risk. Mose, what do you think of that statement or misconception?
That is a big misconception. In my opinion, I mean, if we're talking about arc flash, low voltage typically is where the highest arc flash hazards are because it's about available fault current. When we talk about low voltage, people don't have the same fear or respect as they will when you say that's medium voltage. Because once again, medium voltage is something that most folks don't deal with on a daily basis. So when they hear medium voltage, they're like, whoa, not touching that. But when they hear 480, they hear 277, or for worse, they hear 120 volt. That's like playing with candy right there, right? And once again, it's the most common voltage that's available. And it's also, and Dave can double check me on this, it is the voltage that most commonly results in shock hazards or shocks.
Yeah, electrocutions, statistically, there are more electrocutions at 120 volts than there are all the other voltages put together. And to Moses' point, you see, 120 volt circuit, no big deal. You see 120,000 volts, you run the other way. So we have no respect for it. We think it's safe. I mean, it's got to be safe. They put it in my house. So, it's got to be a safe voltage. But when you lose respect, you lose, and I asked the question to the people on this phone here, how many of you actually use lockout, tag out in your insulated gloves when you change the ceiling fan at home? Do you really?
I really do. I really do. I really do.
Yeah.
My awareness has been raised, and I cut a wire on the top of my house one day and almost fell off the roof because I didn't do that. So.
Yeah, I did it one time with a ceiling fan on my shoulder, and someone else turned the light switch on for me. Yeah. But the way that rumor or that misconception, low voltage, especially around motor control centers, you have to have a really stout power supply, a lot of fault current available, not fault current, but starting current for those big motors. And all those motor control centers typically have a retarded protection to allow for the inrush of the motors themselves. So, and I don't mean retarded because it's stupid. I mean, it's slowed down. So your exposure time and the amount of current is much higher than at a medium voltage or a higher voltage situation. Very rarely do we see over 40 calories at 15 kV. Very rarely, but you see it all the time at 480 volt.
Absolutely.
Yeah. Along that same line, what do you think about PPE misconceptions?
Yeah, I'll start. I think two misconceptions related to PPE. One is that PPE is the first line of defense. I think a lot of people say, I'm just going to put on my PPE and I'll be safe because I'm wearing my PPE, I'm wearing my gloves, but it's technically the last line of defense when you can't reduce the hazard to an acceptable level of risk. Just like a seatbelt in our car. Our cars are super safe these days, but there's still, we need our seatbelt to get it down to a level of risk that's acceptable. So once again, I think that's one. And then for me, the other one is that the difference between troubleshooting and working on. A lot of people like, well, I was only doing troubleshooting when an event happened. Well, just because you're doing troubleshooting doesn't eliminate the need to wear the appropriate PPE. So once again, people need to know that just because I'm doing troubleshooting doesn't eliminate the need for PPE, because a lot of people know that if I'm working on, well, I need the PPE, but it's you need it for both. The differences in the energized work permit.
Yeah. Just another comment on this topic. Another misconception we don't typically talk about with PPE is breakthrough.
You know, I was about to address that. You know, when we put these warning labels on the equipment, the value of the incident energy on that label is a calculated value that gives you a 50-50 chance of surviving. So when you put on the appropriate PPE, that's a 50-50 chance of avoiding a third-degree burn. So it's not 100%. It's not guaranteed. And some of the I guess misconception in there is, well, you know, it was 11-calorie hazard. I was wearing a 12-calorie suit. I won't get burned. That's not true. If you have a fault and you're within that approach boundary, we're only limiting it to a 50% chance. So it is not absolutely safe. Now, you just mentioned breakthrough. Are you talking about energy breakthrough ratings of fabrics, EBTs?
Mm-hmm. I believe so.
Yeah. So that was an often ignored element of safety materials. Back when we created ASTM 1959, we looked at both the thermal protective value of the fabric and the energy breakthrough level of the fabric. And we came out with some combinations, had a low thermal energy, but a very good EBT, or a withstandability of that kinetic energy involved with arc flashes. And some of the material didn't fare so well because it didn't have a very good EBT. And if you remember back in the day, for those of you that remember what back in the day meant, there was a restriction that you could not wear polyester or neoprene or some of these other man-made fabrics in any combination, or even under your arc flash protective materials. And now the fabrics that we're wearing today are either 100% cotton, or they're cotton with a high tenacity nylon blended into them. And that high tenacity nylon is what gives that a better EBT. And the cotton fabric is what soaks up and blocks the thermal transfer. So the technology that's gone into our protective equipment has been huge, considering where we were in 2000 versus where we are today. Well, ASTM 1959 was created in 2002, about the same time as IEEE 1584.
Mm-hmm. Which is the arc flash calculation standard.
Yes.
Yes. And speaking of arc flash, it's something I come across a lot. Do you feel like arc flash labels, is it a misconception that they're always dependable? Because it always goes back to the condition of your equipment, right? If something's not operating on time, then what's that label mean?
Do you have access to your email, Justin?
Yes, sir.
Check your email real quick.
Oh, they got some kind of little secret going on.
Yeah. I wasn't really expecting that question, but I can tell you, when we first started doing these studies back in early 2000s, there wasn't really a lot of experience amongst the engineers that were doing the studies. In fact, there was a lot of organizations that didn't even have engineers doing these studies. They said, here's this little Excel-based, macro-based calculator. Go out and create some labels, or Even SKM or Easy Power, some of the other software, the modules were brand new. A lot of people didn't understand, and because of that, we have some horrendous labels that are on different pieces of equipment. And that's what I sent you, Justin. It was a copy of a label that's an actual label that I found in a facility. It was like, you got to be kidding me. And we hope that these labels that our people are depending on for their life are being produced by qualified engineers, professional engineers who have experience using the software and experience performing these studies. Not all engineers are the same. And we have design engineers that don't even want to touch our flash projects. So the quality of a label is very reflective of whoever did it.
Right.
Because there's things in the software that are set by the engineer. And if he doesn't take some due diligence in understanding the criteria of where that label is going to be, then you're going to end up with some really bizarre information or under protecting those. And one of my least favorite places to put a label is on bus duct. Yeah, the calculated value is maybe 8 cals or something like that, but you're in a man lift. And you're strapped in if you're in the man lift following OSHA rules, and you're up 40 feet in the air. Are you going to be able to get out of that hazard in 2 seconds or less? No. So you have an extended exposure to that arc flash when you're in particular environments. And if you don't think about that when you're putting that label on that gear, we're setting some people up for some failure here.
Maybe a shameless plug here since I work for CBS ArcSafe, but it sounds like whenever you have some uncertainty around these labels, maybe that's a great spot for remote racking and switching.
Absolutely. And we have customers that go, hey, Dave, that's a really high incident energy on my service entrance. What are you going to do about it? I just did the study. It's the calculated value. I can tell you what you could do about it. You could get some remote racking. You could get some chicken switches. You can get out of that arc flash protection or that arc flash boundary using some of the other devices that are available today.
That's another thing. When think about mitigations, think about tool selection. A lot of incidents happen with improper tool selection. Is that part of the safety briefing back in the beginning to make sure people have the right tools for the job that they're doing that day?
Absolutely. I mean, particularly if there's any energized work, or if you're once again going through the process of lockout, tagout, and applying grounds as required as is compulsory on medium voltage systems, right? If you don't have the right tools, you are definitely putting yourself at risk. One of the tools that I think electricians and people in the industry take for granted is the lowly digital multimeter, and not understanding the proper voltage ranges that tool is designed for. I've seen at least 3 different events where an electrician used 1,000-volt digital multimeter on a medium voltage system, and it doesn't like that, and they were severely injured.
Well, even those things that are considered non-contact tracers, tick tracer. Oh yeah, you can use that on a 4160, but it's not designed for direct contact. You're just supposed to get close. Get close and it lights up or it beeps or something. But some people just forget to stop the Q-tip when they feel resistance.
Yeah.
And multimeters, we restrict our own technicians from bringing their multimeters from home. Yeah. You can go to these low-cost places and buy a multifunction multimeter that's a category 1 or 2 device. And then you're trying to use it in an environment that requires a 3 or a category 4 device. And it's all about the insulation of the device and the ability to withstand peaks from the voltage. And you could end up blowing yourself up or blowing a meter up in your hand if you're not using the right rated device for the position you're working in.
Yeah. We're getting short on time for the hour that we had, but I do want to touch on a couple more questions and maybe even try to get to a couple in our chat. But I will say that if you've asked a question here, we'll take those and make sure we get back to you on your questions. So I'm not going to leave anybody hanging on their specific questions here. There's a lot of talk right now in the industry about shock versus arc flash, and we've paid a lot of attention to arc flash over the last few decades and less so on shock. Where do you think that's coming from? Is shock the predominant risk right now? And where do you think things are headed in the future with that?
I think shock is still the predominant hazard in terms of lethality. More people die from shock than die from arc flash. But the magnitude of damage done by a single arc flash incident by far outweighs a minor shock or even, an unhealthy shock. So the focus is really on the damage done to the human body by an arc flash event. And the technology around arc flash protection has grown in the last couple of decades. The technology around shock protection hasn't changed. We've had insulated gloves for 50 years. We still have insulated gloves. We've got hot sticks. We've had hot sticks for 50 years, and nothing's really changed in technology for protecting our workforce against shock. But a lot has changed in arc flash.
That's a great point.
Yeah, just not as sexy. And once again, rubber gloves are rubber gloves, and they're a great way to protect yourself. Where once again, the attention that was placed on burns via an FPA 70E, starting back in, what was it, Dave, the 70s, is where that kind of got the big press for the last 2 decades.
So looking into the future with the increase in automation and remote diagnostics, do you think the nature of electrical safety is going to be changing, or what should maintenance leaders be thinking about for the next 5 to 10 years? And maybe that's where that digitization reference earlier came from, is all the remote diagnostics that are involved. Is that making things better? I'm sure it is.
I guess it depends, right? I mean, obviously more data is better. We've got trip units out now that will tell you whether your breaker is tripping sluggishly, right? We have just about every device that's being created right now has some form of metering and reporting capability. So that's more data, and that's super good. But I still think there's going to be that human factor on a periodic basis that takes the system down, runs it through its paces, whatever those paces might be, to assess its condition and its operational ability that are going to be necessary, even with the more data and more digitization.
Yeah, I don't think AI is going to replacing a bushing on a transformer anytime soon.
It would be nice, though.
All right. So, in closing for our commentary here, what do each of you think should be a main takeaway for our attendees today?
Go ahead, Dave.
I'd like to think that the attendees in this session are very interested in connecting the dots. And when I say that, I mean between the codes 70, 70B, and 70E. It was a revelation to me when I started reading 70B that a lot of thought went into that document. And if you're familiar with code at all, when you see something new in a standard, it's got that little N next to it as a new paragraph, and a little grayed out kind of N, or if something's changed, there's a little triangle there, meaning a change in something. And that whole document is just full of new, and it's all good. People ask me, well, have you ever seen stuff in the code that just doesn't make sense? It sounds like a knee-jerk reaction, blah, blah, blah. And yeah, I have. But this is the first time that I have seen 70, 70E, and 70B all communicate the same message. And it's all in very clear language. So I'm excited about the fact that we're all maybe rowing in the right direction about protecting our workforce and protecting our equipment.
Yeah, absolutely. And for me, I think it's about the awareness that I spoke of at the beginning, and how the people on this call take the information, because we could go on for another hour, right? But take this information and go get curious, right? Go explore, call one of us, learn some more, and create that culture where safety is a focus of the reason you do maintenance.
Thank you, Mose and Dave. I got a question here from the audience that I just want to lean in here. Linda asks, What is your take on setting up a remote racking device or remote switch operator on equipment not meeting normal operating condition? There's a client that they know that has a possible cause of an arc flash due to equipment condition.
If you don't think that switch is going to open, that circuit breaker is going to open manually, I doubt it's going to open if you put a remote device on it. So that's definitely a situation to consider what you're doing here. I tell my techs, if it won't close electrically, it won't close mechanically, it's not going to close electrically either. So that's definitely a time to take a full outage and figure out what's truly wrong with that device before you try to start forcing it into a condition that it can't be in.
Yeah, I agree with Dave. If you have a suspected arc, you have a concern about the device you're going to operate, go operate the device upstream. If you got to operate it, it's the only device. Remote would obviously be the best way to do it, to not have a person in that arc flash boundary when you do operate it.
Another question we have is, have you seen a big push on 70B compliance from insurance companies?
Yes.
So far, 2 of our customers have asked us for assistance in developing that electrical maintenance program that 70B requires, and it was at the behest of their insurance company. So yes, I think it is picking up.
That's the bulk of what I'm gonna. I see, Mose, you're saying humidity is an issue in customer. Are you answering a question?
Oh, yeah, I'm trying to answer some questions that are in the chat so that people didn't feel left out.
Well, we are running a little bit over time, and I just want to close with a little bit on Group CBS. To first of all, thank you for everybody that attended. We will have a recording of this that will be sent out to you. Questions that you've raised will be answered, and just a little bit more on us. We're here for your electrical safety. If you have questions or other things, just I'll put my email in the chat, and you can send questions our way, and we'll make sure we get those answered. I'm doing that right now.
And be sure and connect with all 3 of us, Justin, Dave, and Mose, on LinkedIn if you're not already connected with us.
Yeah, please connect with us. We appreciate you all attending today. I hope you got some value out of the conversation. I feel like it went in several different directions, but we intended for that. And just a little on us, we're part of Group CBS, and with that, we're here kind of empowering the electrical industry as your life cycle partner. So after installation, you've got field service, life extension, parts and breakers you may need, remote switching and racking through CBS ArcSafe, shop repairs, testing, and also custom engineered products. A whole gamut of solutions for the industry. And we're here for you, whatever the need is. And even if it's not something we do directly, we'll help you find that resource. So, please feel free to reach out. And with that, Mose, Dave, any closing thoughts?
Go forth and conquer, but do it safely.
All right.
Yeah, when in doubt, pause.
Well, I think this was great, guys. Thank you so much. Thanks for being part of the team, and thank you all for joining us.
Thanks, everybody.
Thanks all.